Not a whole lot has changed between EIGRP for IPv4 and EIGRP for IPv6 in regards to the show commands. All they've added was v6. So show IPv6 EIGRP interfaces to view the output of the interface table. Show IPv6 EIGRP neighbors to see which neighbors this router has. Show IPv6 EIGRP topology to review the output of the topology table, which contains all of the routes we have learned from our neighbors. And show IPv6 route EIGRP, or just show IPv6 route to see the routing table. So there's a lot of really great show commands that were part of EIGRP for IPv4 that are part of EIGRP for IPv6. On R1, let's type in show IPv6 protocols. And we can see that we are running the IPv6 routing protocol, and it is EIGRP autonomous system number 100, and it lists it for us twice. We can verify our K values, and these are the default K values for EIGRP, whether it's IPv4 or IPv6. We can see our router ID, 192.1.1.1 in this particular case. That's right, we forgot to set the router ID in my example earlier. So it automatically chose 192.1.1.1. Let's find out why. This is a great time to do that. If we type in show IP interface brief, remember what I said. If you don't specify the router ID, it's going to look at IPv4 enabled interfaces. Well, in this case, we have how many? We have 1, 2, 3, 4, 5, 6. So how did it choose this one? Well, it first looks for loopback interfaces, and it found one. Now, if there was 2 or 3 or 4 or 5 loopback interfaces on this router, it would then look at all of those loopback interfaces and choose the one with the highest IP address. Well, in this case, since there's only one, loopback 0, it utilized this IP address as its router ID. If the loopback interface wasn't there, then it would have gone through all of the interfaces that we see, the physical interfaces, or logical or sub-interfaces associated with a physical interface, and at that point, it would choose the highest IP address amongst those interfaces. So if it wasn't for this one here, it would have used this one, 10.1.13.1, because it's the highest amongst those physical interfaces or sub-interfaces associated with the physical interfaces. Let's go back to our show IPv6 protocols command. We can verify the number of equal paths for load balancing, and it's 16 by default in this case. Maximum hop count is 100. Remember, it is a distance vector protocol at its roots. Therefore, there is a maximum hop count of 100. The variance is set to 1 by default. And down below, we can see which interfaces are participating in this routing process for EIGRP Autonomous System 100. And it's Gigabit Ethernet 1/0.1 and Gigabit Ethernet 2/0. So these interfaces were enabled using what command? The IPv6 EIGRP Autonomous System Number command in interface configuration mode. And if this router was performing redistribution, we'd have some information down here in regards to the redistribution that was happening. The next command we want to look at is show IPv6 EIGRP interfaces. So this is going to show us the interfaces that are participating in the EIGRP process. And in this case, it's the Autonomous System 100 EIGRP process for IPv6. Interface Gigabit 1/0.1 and Gigabit 2/0 are both participating in this EIGRP autonomous system. We can see that we have no peers out the Gigabit 1/0.1 interface, which would be this interface connected off of R1. And the gigabit 2/0 interface has one peer. So we expect that. The next command we want to look at is the show. The next command we want to look at is the show IPv6 EIGRP neighbors command. And in this output, we can see those directly connected routers that we have formed an EIGRP neighborship with. And the big difference here is the link local address that is listed as the neighbor's address. So this link local address is FE80:31. So let's go over to R3, because according to our topology, R3 is directly connected to R1. If we go over to R3, we should be able to verify this particular address on one of R3's interfaces. So we'll type in show IPv6 interface brief on R3. And what did we say it was? Let's go back to R1. FE80:31. If we go over to R3, it is FE80:31 gigabit 1/0. Let's double check that. And yes, it is. R3's gigabit 1/0 is connected up to R1. And that's the link local address that is used to form the neighbor adjacency with R1. And to get to this neighbor, R1 is going to use its local interface of gigabit Ethernet 2/0. The next command we want to look at is the show IPv6 EIGRP topology. And this is going to show us our topology table. Scroll back up. This topology table is associated with EIGRP Autonomous System 100 for the IPv6 protocol, and the router ID is 192.1.1.1, so it's this router's topology table. The same codes that we have with IPv4 EIGRP we have here. And we can see all of the routes we have learned. And if we look really closely, everything we have learned is from R3. Absolutely everything. And how do I know that? Because it's telling me next hop is FE80:31. If we go down through it, that's all we see is :31 as a next hop that can be utilized in order to reach these particular destination networks. But if we look closely at it, we can see that the address is specified, the particular destination network that's being advertised. Successors, it says 1. That means there's one best path. And the best path is the one with this particular feasible distance. Now that's a rather large feasible distance. And if we look at the topology, you'll see that 456:4 is that frame relay link between R4, R5, and R6. So that would have been redistributed from OSPF into the EIGRP process. And that's why it has such a large feasible distance, because when we set the metric during the redistribution process, it was set to a rather large number. But if we scroll down and let's go take a look at the link between R2 and R3, which would be 23::, and we can see that there. That's a much nicer feasible distance. As we can see, it's 3,072. In this case, it is installed in the routing table. We get there via R3. There's the feasible distance of that particular route, the reported distance of that particular route. So this is what R3 is telling us, how far they are away from that particular network. And then we add to that R metric to get to R3 to come up with this value here, and the interface that we use to reach the network. The last command we want to look at is show IPv6 route. And this will show us all of the routes, whether they are static routes, local routes, directly connected routes, EIGRP learned routes. And this is the EIGRP route that's inside of our autonomous system. That is the route between R2 and R3. And if you recall from the topology table, it stated that there was one successor, and this is it, via FE80:31. So D is still the code in the routing table for EIGRP, whether it's IPv4 or IPv6. And there's no confusion here because we are specifically looking at the IPv6 routing table. We're not looking at the IPv4 routing table in this case. So there's a big difference, right? They're two completely different data structures. We have the IPv4 routing table, IPv6 routing table. They don't mix. So D is still the code. Destination network. This value here, if you recall, is the the administrative distance, the believability of this routing protocol versus other routing protocols and static routes and connected routes. And so therefore, it's still 90. It's not changing. It's still EIGRP. Feasible distance is listed next hop, and the interface we use to reach the destination network. And you'll see that for the external routes, the routes we've learned that are outside of the autonomous system, well, these ones have the EX beside them.